Okay, hello. Today we're going to talk about binary search, which is often a good technique to optimize your solution for for problems that have certain properties. For example, if the data is in some way sorted, then very often you can use binary search. And so one thing I want to talk about binary search is the template. I learned this from school last semester and I found it very useful. So when I first learned binary search, this is what the professor told us. And this is the typical example that will be given in lecture, which is given a sorted array. And can you find me the index of a particular target element, say 7? And if the number is present, if you found it in the array, then you return the index. Otherwise, you return some special index, for example, -1. And how do we solve this problem? And what is the general template for a binary search? It is something like you have a low and a high, and you check the middle point, and if the middle point is equal to the target, and then you found the answer. Otherwise, if it's smaller, then you cut the first half and you only consider the second half. Or if it's larger than the target, then you only consider the first half and discard the second half. But today I'm going to present a new template to think of binary search, which I found more useful when you have to convert the problems and you have to apply binary search to the problems, which is this. Imagine you have an array of Boolean variables, and the Boolean variable has a certain property. It starts with false, followed by a sequence of true and no false. There's no false once you see a true. So it would be false, 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 true, 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 a pattern like this. And the question would be, um, can you find me the last false or the first true in the sequence? Can you find me the index of that? And here is a simple template that you can follow, where we first initialize the low and high pointer to be 0 and the length of the array -1. So, and here is a key invariant that we have to maintain during our binary search, which is array low is always false and array high is always true. So in a sense, low pointer will start from the first element, which is assumed to be a false, and the high pointer will start with the last element, which is assumed to be a true, and they will move toward each other until they finally meet each other in the middle, where the low pointer will point to the last F and the high pointer will point to the first true. And here is a simple template that you can just blindly type, and I feel I found it works most of the time. You don't have to adjust anything. Unlike the previous template where we have to spend a lot of time thinking about the condition right here, in this template, which I will show you why I claim that, and I, you don't need to modify the template, the framework at all. So this is the template. Well, low plus 1 is less than high, meaning um, while the two pointers, low and high, before they meet each other in the middle, you keep doing the loop over and over again. And the first step you do is to find the middle point. And then you check whether the middle point is true or false. If it's a true, meaning the middle point is a true, then that means everything to its right are true. Then that means you should decrement high to be mid. In other words, you should discard everything to the right of mid because you know for sure that all that elements will be true. So high will be mid, and otherwise if it is a false, then by the same reasoning, you should increment low to mid because you know that everything before mid will be false. And by the time you exit this while loop, when will you exit the while loop? It will exit the while loop when low plus 1 is equal to high, which means when high is immediately after low. So basically they meet in the middle, and that is the exit point. And now we know that low will point to the last F and high points to the first true. And now according to your question, whether you want to find the last false or the first true, you can return low or true, low or high, sorry, accordingly. So now I'm going to explain from a high level why this template and why thinking of binary search as finding the last F and the true in some array would be helpful. So most of the time, you need to first convert the problem such that it looks something like this, which is it's an array of not elements, but it's an array of Boolean variables of false followed by a sequence of true. And you convert the desired property, the desired target, to be the last F with the first true. So take a simple example. Let's say you have an array of sorted numbers. And you want to find the target of some, and you want to find the index of some target, let's say 100. And the way you can convert this problem to this template is to first define a little checker, and the checker will spit out true or false, uh, depending on whether that number at index I is larger than or equal to 100. So if we define checker of I to be whether array I is larger than or equal to target, then if we apply this checker, which is you can think of it as a predicate function, as a predicate, then if we apply this predicate to each and every element in an array, then effectively we converted this array to a sequence of Boolean variables, where you can see that, yeah, if we apply the checker to the first element, 0 is not greater than or equal to target, so it spits out false, false, true, true, true. So now you can see, oh, then the problem becomes, okay, find me the index of the first true according to the definition of our checker. So then you can apply the same template, the same code written right here, and now you should return high because high points to the first true, and according to our setup for the checker, then we know that the first true will be our will be the index of the target. And of course, in this case, what if the target is, for example, 101, where it's not present in an array? Then we can still do the same thing. We can still use the same checker, convert it, and apply the same template. But now instead of blindly returning high, we should check whether uh, whether the element at index high at the end of the binary search is indeed equal to 101 or not. Because in this case, if target is 101, then the array will be something like after the conversion will be false, 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 true, true. And you find the first true, which is 123, 123, and you check whether 123 is equal to target. And you find out, okay, it's not, and therefore target is not present in the array, so it should return some error index, for example, -1. And as you will see, if you try to, at least personally, I found that this template is very useful. I can almost always find such a checker, and I can find a checker such that I can apply this checker to the original array, so that I can convert the problem to this problem where you just need to, you have a sequence of false followed by a sequence of trues, and you need to find the last false or the first true depending on your setup for the checker. And now let's see a concrete example of an application for binary search. So let me see. So this is the problem. Okay, so the problem is that we have a sorted array in ascending order, but however that this array is rotated at some pivot unknown to you beforehand, and we want to find the minimal element. So for example, if the original sorted array is 0, 1, 2, 3, 4, 5, 6, and somehow it is rotated at some unknown pivot, and it becomes 4, 5, 6, 7, 0, 1, 2. So it is not sorted, but again, it's like partially sorted, and we want to find the minimal element. Of course, a trivial solution would be to iterate through the whole array and find the smallest element. But we know that, okay, if the array is sorted but not rotated, we can definitely apply a binary search and find the minimal element. In that case, there will be the minimal element. It will be always the first element. So it's trivial, but now it's rotated, but still sorted. One thing, one way we can approach this problem is that, okay, if we can find the index I such that I is the index after which the element the element is smaller. So if you look at this this input 4, 5, 6, 7, and if you say, okay, look at the first element 4, whether the next element is smaller than it or not. In this case, you will see that, oh, the array will keep increasing until some point it will go back to the smallest point and start increasing again from there. And that sort of, you think of it as a curve or a function that keeps going up, and all of a sudden it jumps down to some point and it keeps going up again. And that jump in the function, or no, in the trend, is the element that we're looking for. That jump, that valley, is the minimal element we're looking for. So if we can find the index such that the I is the index after which the element is smaller than it, then we know that numbers I is equal to the answer. And now the problem is, how can we efficiently find the element such that the immediate next element is smaller than it? Can we somehow apply the binary search technique here? And yeah, let's try to follow the template and see how we can convert the problem into this canonical example and apply, and therefore we can use the template. So one thing you can do is that by observation, you realize that, okay, if it's rotated, then that means most of the time the array will keep increasing, and all of a sudden it will decrease to another number and start increasing from there again. So if we define a checker, and the checker of I says returns whether or not nums I is smaller than nums 0. Then if we apply this checker to each and every element to the input array, then the input array becomes a sequence of Boolean variables of false, 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 true, true, true. And for convenience purpose, we'll just write it as false, 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 true, 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 something like that. And we know that then the first true, which is the first element, such that the checker returns true, which means the first element that is smaller than the first element in the array will be the answer we're looking for. The first true will be the smallest element in the whole array, because we know it, the trend will be increasing, down, increasing. So the first time we go down, and we'll guarantee that that number is of course smaller than the first number in the array. So the first true will be our answer, the answer we're looking for. Yeah, so then we can convert the problem and apply this template and return high, and that will be the solution for this problem. But there are a few caveats when you want to apply this template for binary search. The first one is, now I'll just write it here. Let me put it into exclamation marks to mean that it's caveats. It means it's important. So the first one is, you have to have at least 2 elements in the array so that you have at least 1 false and 1 true, and it's a false followed by a true. So at least have 1 false and 1 true. So what this means is that if you have a sequence like all Fs or all trues, then you have to consider them separately as special case. That means you don't have to run this. You don't need to run this while loop. You can just check, okay, whether the first element or the last element satisfies some special property. Then you can say, oh, if that is true, then is this case that corresponds to this case or this case, and we can return the answer. So typically this means all false means, okay, no element in the array satisfies the checker. So then that typically means that the answer you're looking for is either the first element or the last element. And the same argument is true for the case of all true. And the second one is not a caveat, but it's keep in mind that the template will always guarantee you that low points to a false and high points to a true. So you don't need to worry or spend extra effort to maintain this. The template code will do that automatically for you. But keep in mind that this is the invariant of this technique, which is low points to false and high points to true. So essentially, there's only one caveat you have to be careful, which is there has to be at least one false and one true. Otherwise, if you just blindly run this part of the while loop, then you would something will be incorrect. Okay, so in this case, you do have to consider the special case of after you apply the checker, you have to consider the special case of all false or all true, and maybe there's only one element, because in that case there will be only one, either one false or one true. And then you can consider the general case, the majority case, which is a sequence of false followed by a sequence of true, and you should just return high or num index high. So to be a little bit more concrete, then in this case, if we apply the checker to each and every one element in the array, okay, what kind of input would produce a sequence of all false? That means no element in the input array will return true. All of them will return false. That means all of them number will be larger than or equal to numbers the first element. So that means the input is already in perfectly ascending order. Say, for example, 0, 1, 2, 3, 0, 1, 2, 3. Because in this case, if you apply the checker, if you compare each and every element in the array to the first element, then the checker would say false, 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 false. What about the case of all true? That means all element will be smaller than the first element. So this is impossible in our setup for using this checker, because at least we have one false, which is the first element. Yeah, because the first element is equal to itself. So for the first element, the checker should always return false. So a sequence of all truths is impossible. What about one element? So if there's just one element, no matter it's a false or true, we should always return the first element, the first and only element. And then for this case, where we have a sequence of false followed by a sequence of truths, then we can blindly write down this template and return high. Okay, yeah, and that is the algorithm. So now let's quickly implement it. So now let's see. This is impossible. Let's do this first. So let's first define the checker. So the checker will return nums I less than nums 0. And we're going to say if. So for this case, that means it's all false, meaning if the last element is false, we never get the chance to see a true. So if checker nums and the length of the last element is equal to false, so we negated that. So if that is the case, meaning if it's all false, then we should return the first element. And very nicely, you will find out that, okay, for this case where we have only one element, and this statement will handle this case as well, because when you input the first element to the checker will return false, and this will be satisfied, and then we're going to return the first element. And in this case, the first and the only element. Okay, so this line handles this case and this case. Now we can safely apply the template for, because we know that, okay, if the code doesn't return from here, then it must have at least 2 elements with at least one false followed by at least one true. So we can apply the template. Just copy and paste the template right here. Change the name. And then return nums high, right? Because high points to the first true, and the first true is the result we're looking for, according to the definition of our checker. Yeah, let's see. Oops. Okay. Oh, so it's not, so the checker, so here we have to apply our checker. So self checker nums mid. If the checker says true, then high is equal to mid otherwise. Okay. Yeah, okay, it passed the test. Yeah, and that will be it for today's video on binary search.